Okay, you guys need to tear off this sheet that is used as a reference. Now flip it over so you can see this stuff, okay? Okay, now we're dealing with inequalities today. I want you to circle that word. Inequalities means greater than or less than. When the nose is like a nose. It's going to the right, it's greater than. Going to the left, it's less than. Nose points right, greater than. Nose points left, less than. Okay, this is pretty easy. Okay, you're just writing write an inequality that represents each verbal expression. X is less than or equal to -7. Okay, so look inside that bubble there. So it says is less than or equal to -7. So less than or equal to is this. Okay, that's less than sign. You just put an equals, and then you put your this is called your critical number, or critical value. We'll just call it critical number, -7. Now outside that, you just have the x variable. That's your answer. Okay, no big deal. Okay, p is greater than 1.5. Okay, so greater than, but no equal to. It didn't say greater than, it just said greater than, and then your critical number is 1.5. Now you're going to put just the p variable, so p is greater than 1.5. Okay, next problem. 6 less than a number k is greater than 13. So this is where the inequality is at. Okay, so greater than, no equal to, and 13 is a critical number. Critical, 13. Now you put your k, but what about that 6? Now, less than means minus, okay? So after the k, you're going to put -6. 6 less than k. You don't just that. Now less than, when I have less than, I don't mean this sheet here, okay? That means I have it circled with the inequalities, okay? The sum of x and 7 is, I obviously misspelled, is less than or equal to -3. So you put your less than or equal to sign, and your critical number is -3. So you put your x variable. Now there's a 7. Now I see that word sum. Sum means plus, so you put +7. Okay, and that's it for that page. Now, there's kind of 4 parts to this, so determine whether, I don't know how to spell whether, I did a terrible job writing this. Determine whether the number is a solution to the inequality. Now we actually did this at the beginning of the year in extended algebra, okay? This means 2 times x plus 1 is greater than -3, okay? So remember that run right there means greater than. Now, what you're going to do is plug -1 into the expression for x. X is going to be out. So you're going to put this -1 in place of the x. Then +1 greater than -3. So, all the actions taking place on this side, so you circle your times first. You always times first. So 2 times -1 is going to be -2. Now take -2 plus 1, you're at -1, greater than -3. Now what's bigger, -1 or -3? When they're both negative, it's like the opposite of 1 and 3. So the lower the negative, the larger it is, okay? So this is a circle the bigger one, and it should eat that number, okay? That's Mr. Payne, okay? Eats negative, shout out to him. Eats -1, so that's yes, okay? Yes, put solution. Don't just write yes, put solution. You're either going to write solution or not a solution. Okay, next one. 13 minus 7, make that plus negative, and then 7 times y. Now you're going to replace the y with 1. So 13 plus -7 times 1 less than or equal to 6. So I got 6 on this side. I got to find what's on the other side. So I find my times. -7 times 1 is -7. Then I add 13 and -7. 13 plus -7, and that's 6. Now the numbers are equal, so there isn't a bigger number. So if the numbers are equal, you see if that line's there. It says less than or equal. So if that line's there, it's a solution. Now, if that line wasn't there, it would be not a solution. Okay. Our next one, negative 4 times x minus 3 plus negative 3 greater than or equal to, remember that means greater than or equal to, negative 17. So you need to put 5 in for your x. So solve this side. Negative 4 times 5 is negative 20. And then negative 20 plus negative 3 is negative 23. Use a calculator if you need to. So what's the larger number? They're not equal, so what's the larger number? Now if I have two negatives, the smaller the negative, okay, because on your number line, okay, the smaller the negative is a bigger number, okay. Does it eat that number? No, it doesn't, so it's not a solution. Okay. Now, next problem, we have 10 minus x divided by x is less than or equal to negative 60. X equals 0.2. Is that a solution? By the way, when I say solution, that's not your only solution. You have a ton, you have like an endless number of solutions. You're just seeing if that's one of them, okay? Like here 5 isn't. You don't need to find what would be a solution. You just know that 5 is not in there. Okay, now, you're like, would I plus negative that? Don't plus negative in front of a letter when you have something to put in for the letter. Please don't do that, okay? Like I was plus negative in there because there was a 7. Plus negative there was a 3. Now, when I have a letter, I don't want to plus negative just yet. I want to put 0.2 in for x here and here. So, you're going to have 10 minus 0.2. Divided by 0.2, and you have negative 60. Now you can make it plus negative now that you have a number, but you don't want to plus negative with a letter, especially if you have something you're about to put in for it. So I find out what the top is before I divide, because I know I have to divide, but I need to figure out what we have on top. So I go 10 plus negative 0.2, and that's going to be 9.8. Then I will take 9.8 and divide it by 0.2 and I get 49. Now if I have a positive and a negative, the positive is always bigger, okay? Does it eat the positive? No. So it's not a solution. Okay, now here's what you're doing on the next one. Graph each inequality. That is less than. Okay, just put a little less right there. X can be, X is a letter. It can represent any number as long as that number is less than 1. So that's like a ton of different numbers, okay? So if I'm thinking numbers that are less than 1, you know, 0, negative 1, negative 2, X can be any of these numbers. I mean, here's 1, these are all the numbers less than 1. And it goes on forever. So what you can't list every single number possible. That you'd be here for an eternity. So what you do to represent that is you make a graph, a number line graph. You're going to put 0 in the middle. I'm always going to be putting 0 in the middle so I know where negative 1 goes. So I want you to put 1 right there because it's positive. Then you're going to circle. Now, the circle is going to be open or closed. Now, it would be open because it's not equal to 1, just less than 1. So leave it open, and you make a line going that way. Now, up above your line, I want you to put what that is. X is less than 1. So that's telling me X can be any number as long as it's less than 1. Okay, A greater than or equal to 0. So all you have to do, so look at your number line real quick. So you're at like 0. Now it's greater than, so it could be anything this way. So you don't need it. You just put 0 down. Now, you are going to close the circle because you can be equal to 0. A can be equal to 0, and it can be anything greater than 0. So we go this way. Up above, just put A greater than or equal to 0. Now, you need to watch out on this one. Notice how the letter is before the number. The letter is before the number. The letter is not before the number. So you do not graph this yet. You need to do what's called reorder. You put the x before the -2, and then you need to change the sign to the opposite and cross that out, okay? So now that's less than, okay? -2 is greater than or equal to x, and x is less than or equal to -2. So I need the variable to come first, and you can't get so sidetracked that you miss that. So circle, fill it, less than -2, so that would be this way, okay? Okay, now up there, copy that down. Remember, your x less than or equal to -2. Remember, because this graph represents everything x could be, okay? So I need x coming first. Okay, now letter, number, you can put a check mark. You do not need to reorder, okay? F is greater than -3. So you leave it open because it's not equal to, only greater than, so we'll go this way. Okay, there we go. Okay, next one, 8 greater than or equal to b. Well, I need to reorder this. I need the b first, followed by the 8. Then if you reorder an inequality, then the sign would flip. If 8's greater than b, then b is less than 8, with the equal still there. So 0, you put 8, you close the circle because you can be equal and less than 8. So anything this way. So like 7, 6, 5, 4, 3, 2, 1. Heck, it could be decimals. It's continuous, okay? And it goes into the negatives and goes forever, okay? So then I put b less than or equal to 8. Okay, x greater than or equal to -2. Check that because your x comes first, the letter then the number. The variable needs to come before the number. So then I take it to the number line. Okay, you can close a circle, then greater. Okay, just like that. Okay, -9 less than or equal to c. So, you need to reorder this, okay? I need the c variable to come before the -9. -9 is a critical value, but if I graph that with that sign, the less than, I'll have the graph going the wrong way. Because see, -9 is less than c, so c is greater than or equal to -9. So you plot your -9, you close the circle, and then greater than would be this way. Okay, a greater than or equal to -20. Now, letter, number, that's good. That's how I want it. Fill it, and greater than would go this way. Okay, now you have the graph and you're writing the inequality. Just write it up above it, okay? So, use x for your variable. It should come first, then the 3. If you're confused about what should I put, 0 or 3, it's always where the circle's at. The circle's above the 3. And then from the circle you're going this way, which is less than, okay? So less than. Now it's open so you don't put the equals. Next one, x, -2 is where the circle starts, and then it goes greater than, okay? Because all these numbers going this way are greater than, so that means x can be any number greater than -2. Keep it open. Okay, x, 0. So the circle's actually above the 0 here, okay? Going this way, that would be less than or equal to. Okay, x, 1. It's going this way would be greater than. It's closed, so it would be equal to. Okay, that's it.